Welcome back, students. So in this video we'll be doing exercise 1.1. okay, but before we proceed, let me just give you a little bit introduction of chapter 1. It's actually real numbers, right? So a real number is numbers that actually exist. Okay, all the numbers that exist is called a real number. Okay, so real numbers could be -2, it could be 0.5, it could even be √2 or 3.5. All these numbers that you see are all real numbers. Clear? So real numbers are integers, they are called represented integers. They're also it's just any numbers, integers, rational numbers, okay, rational numbers, irrational numbers, all of this. Okay, clear? So under integers, even, odd, everything comes in, right? Even, odd, natural numbers, whole numbers, all the numbers that exist is called a real number. Okay, but before we proceed, exercise 1.1 actually deals with a very important concept called the Euclid's division lemma. Okay, so it's very simple. You have been doing it since you were kids, ever since you were young, but you just don't really pay much focus to it. Okay, so what does Euclid division lemma tells us? That if there are two integers, okay, if a and b are, they have given strictly a and b are positive integers, okay, then there exist unique integers, okay, unique integers q and r. See, this is in your page number 3, okay, q and r, which satisfy a equal to bq plus r, and remainder should be less than or equal to b, or okay. So you do not have to worry about this statement. So you remember what is integers, right? Integers are all these numbers, plus, -1, plus, -2, plus, -3. These are all integers. Okay, see, 0.5, √2, √3.5, these are not integers. Okay, so integers are this. Okay, 0 plus -1 plus -2 plus -3. All right, these are all integers. Clear? But they have specifically said a and b are positive integers, so we can only consider 1, 2, 3 and all of that. Okay, 1, 3, 4, 5, all of that, right? You cannot include 0 because 0 is neither positive nor negative. All right, so only positive integers. Then there exist unique integers q and r, so they would exist again, unique integers. Okay, it will be different for every number that you put. It's going to be unique. Okay, and what's given here is r must be less than or equal to b. In fact, this you will be studying in chapter 2. It's nothing but dividend into divisor into quotient plus remainder. This is what it actually means. Okay, clear? Now let me just give you an example of why this is given, why r must be less than b. So what is b? B in the case of this is going to be divisor, right? B is the divisor here. Okay, b represents this quotient q and then remainder r, and then a represents the dividend. All right, so the remainder must be less than the divisor. So see, it's something like this. Okay, suppose you have a number a, so that is our dividend, so 5. What is the divisor? I'll take my divisor to be 2. All right, so 2 into 2 becomes 4. So what is left? A. So what does this Euclid's division lemma? It tells us that the dividend, which is 5, is equal to, what is the divisor over here? We took 2. What is the quotient over here? We took 2 plus remainder is what? 1. This is what Euclid division lemma mean. Okay, now when you pay focus on this r, what is r in the case of this example? For 5, the remainder is 1. Clear? And what does this tell? That remainder must be greater or equal to 0. Okay, it should be greater or equal to 0. It can also be 0. Okay, that is what this lemma tells us. So greater than 0, so definitely it is 1, so it's greater than 0, satisfied. Now r must be less than b. What is your b over here? B is the divisor, so this is nothing but b into q plus r. Okay, so now what is b over here? It is 2, right? Now you check, is the remainder less than b? Obviously, right? 1 is definitely less than b, because in case if the remainder happens to be greater than b, example, okay, just take an example again. Say let's go with a slightly higher number, like 4, maybe 4 and 13, 16, okay, 17, Okay, I'll just take an example, okay, of this sort. All right. But okay, so because the thing is, remainder should always be less than b, okay, because if the remainder is greater than b, that means if, just take an example here, okay, if remainder is 3, you have to keep on dividing, right? So after you divide this, again you'll be left with one denominator with one remainder 1. So no matter what sort of division you do, you should always notice that the remainder will always be less than the divisor. Clear? So I'll just give you one more example. Let's go with 11th or 13th and 4 or 3, okay, or let's go with 5, okay. So 5 times 2 is 10. So what is left? 3, right? So by that Euclid's division, this is going to be 13 is going to be equal to 5 into 2 plus 3. This is A, the dividend. This is the divisor, which is B. This is the quotient 2, and then this is the remainder R. Clear? Now remainder is, again you check, remainder is 3, divisor is 5. So 3 remainder is always less than, so will always be less than B. So suppose it is 10, 5 times 2, 10. Now you look, you have an equation which is 10 into 5 into 2. What is the remainder over here? 0. So R is equal to 0. This is also possible because the statement tells us that R can be greater than 0 or it can be equal to 0, okay. So here in the case of this, we're getting it equal to 0, so this is also possible. All right, so for exercise 5, exercise 1.1, we're going to make use of Euclid's division algorithm. Okay, it uses these concepts only. Okay, we're going to be using this concept, okay, of how we do dividend equal to divisor into quotient plus remainder. This is what we'll be using it for this, but it's an algorithm. Okay, so an algorithm is actually a step-by-step process. It's a step-by-step process which should be correct, which means it should be well defined, okay, and it will help you to get an answer. Okay, it's a step-by-step process. Understand? Okay, so this is the first question we were given. We're asked to find the HCF, which is also called the highest common factor. Okay, highest common factor. Now you already know what LCM is, right? Least common factor, right? Least common factor. This is highest, okay. This is least and this is highest. So for least, it's very easy. The common factor between these two is going to be 5, right? This 135 and 225 can both be divided by 5, right? Okay, in fact it's 3. It can both be divided by 3 as well. Okay, so the least LCM for this given is going to be 3, but they're asking highest factor. So in order to find out the highest factor, what we do is we use division algorithm. So the step is this. Okay, it's a very simple step. First thing, which is greater, 135 or 225, which is greater? So obviously 225 is greater. Because 225 is greater, we will use division algorithm. So it's going to be 225. Let's see. We use the division algorithm. Since 135 is less than 225, we divide 135 with this. So you just look at this, okay? So 135 times 1 is going to be 135. Okay, if you take 135 times 2, you'll get a higher value. You'll be getting it as 270, so you cannot do that. Okay, so this is going to be 0, this is going to be 12, and so this is going to be 9. So it's going to be 90. Clear? 225 minus 135 is going to be 90. Next, so what is 225 equal to? It is nothing but the divisor into quotient plus remainder. After this, what you're actually supposed to do is you're supposed to divide now. Now what is your divisor over here? Your divisor is 90, and what should be your dividend? So it should be 135. Okay, you have to bring 135 over here. All right, now you divide this. Okay, 90 times 2 is 180, but 90 times 1 is 90. So you can always put here 5, and 13 minus 9 is going to be 45. Therefore, what is our new dividend over here? Your new dividend is 135. What is the divisor? The divisor was 90, right? We divided 90 into, and the quotient is 1, remainder is 45. So we need to proceed this till we get our remainder as 0. Okay, so let's again go. So 45, now 45, I'll just try to, okay, we'll do it till this much. Now what should be your dividend? Your new dividend should be this. Okay, 90 again. See, first it was 35, next this, okay. So we're going to be dividing 45 with this. In fact, 45 2 times is 90. So finally you can write, what is your dividend over here? It is 90. What was your divisor? 45 into 2 plus 0. So divisor into quotient plus remainder. Remainder is 0, it's correct. Now you check here, remainder is less than 90. 90 is less than 135. So those conditions that were set up by Euclid's division lemma are set up in Euclid's division lemma is satisfied. Therefore, the HCF, okay, of the highest common factor of 135 and 225 is 45, okay. Okay, that means 45 divides both 135 and 225, and that's the highest, okay. Beyond that, you will not find any numbers which will divide both these cases, both 135 and 225. All right. Now let's go with this, okay. So again, here it's very easy, right? 196 and this, which is greater? Obviously 38,220 is greater. So what I'll do here is I'll take division over here, okay. Now it's a huge number. So what will we do is, what is our division in the case of this? This is this, right? So let us try division here. You don't necessarily have to take one number at a go, but in fact, we'll do it one by step. So 196 times 1 is 196. You don't write anything over here, okay, right now. This is going to be 12, and this is going to be 2, and this is going to be 17, right? So 382 minus 196 gives you 186, yes? Okay. Now 196 and 186, which is greater? Obviously 196 is greater, so you have to bring down 2. Okay, I hope you're clear with this. So this is 1862. 196 into 10 is 1960. So the answer would be 196 into 8 will give you, okay, 196 into, sorry, what, not 196 into 9 will actually give you 1700. See, 196 into 9, because 196 into 10 gives you 1960, which is greater than this, so you cannot. So obviously the next value should be 9. So 9 times 4, 80, 81, 86, 8, so 1764. Okay, so you subtract that and you see what you're getting. So this is going to be 980. 98. What is remaining? 0. So let's see, 196 into 5 is actually, 196 into 5 is what? 980. So what does this understand? What does you get from this? 38,220 is, what is the divisor over here? 196. What is the quotient? 195, and the remainder we got is as 0. Therefore, the HCF of the highest common factor of 196 and 38,220 is 196. 196 divides both 196 and 38,220. All right. Okay, you just see it's a very huge number, so you follow this step, okay, which I think you have learned this when you were young. Next is, we'll go with this, okay. So for this, 255 is less than 867. So let us go and divide this using division's algorithm, Euclid. So 255 into 3 is, okay, you should try, okay, you just keep on multiplying 255 into 2, 255 into 3, and all of that, okay. So this will give you 765. So this is going to be 8 minus 1, 0, and 102. Clear? So that means 865 is equal to, what is the divisor? 255. The quotient is 3, and the remainder is 102. Now we need to keep on proceeding till we get the remainder 0. So next you'll have to bring this 255, okay, and so 255. Our new divisor is 102. So you just check, 102 into 2 gives you 204. So this is going to become 1, and this is going to be 51. Now, okay. Now 51 divides, now that means 102. 255 is 102 into 2, that is the remainder, plus the remainder, that is the quotient, and the remainder was 51. Next we have to divide 51, and what should be the dividend? You should bring it here, 102. In fact, 51 into 2, right? 51 into 2 is 102. So you can cancel this. So 102 is actually, what is the divisor? 51. What is the quotient? 2. And what is the remainder? 0. Therefore, HCF of 867 and 255 is 51. Okay, divisor here. This was the last number that we divided, in which we got our remainder as 0. Clear? So this is the answer. So we shall end the video here.